Good evening, and thank you all for joining us today. My name is Rashmita, and I'm the event planner for Microsoft Reactor Bengaluru, India. And today we are back with another session from Azure Happy Hours. But before we start the session today, I would like you all to read our code of conduct. We are all here to learn together, so please be respectful of other people's views, understanding of differences, being kind and considerate in the way you engage. The chat will be open throughout, and we do encourage you all to participate. With this, I would now like to hand over the floor to Vivek. Over to you, Vivek.
Thank you, Rashmita. Welcome to Azure Happy Hour. I don't know what is the episode or what is the season because Azure Happy Hour has been running for 3 years now. So welcome. And online audience as well. Welcome to the show. And today we have 3 different topics. And the first topic is on container apps, and the second from Nish, who is a senior program manager, and you can obviously hear from him and amazing demos he has. And the second topic we're going to cover is the Azure functions from a serverless perspective, what you can build with Azure functions, and we will again see a couple of demos. And the last talk will be on the IoT, specifically from digital twins. So we're going to cover a bunch of things in this next 1.5 hours to 2 hours. So we'll go through that. And first up, I'm going to bring in Nish. Nish, you can come online. So Nish is joining us from different place, right? So I'm going to move to the screen here. I'm going to bring you on screen, Nish.
Okay.
So you're on screen
hey,
here.
everyone in Bengaluru. Very nice to see you all. And hello to everyone else joining from the rest of the world. Very happy to have you all here.
So Nish is going to talk about the container apps, and obviously it's a very interesting feature we have and service which we have. And Nish, over to you. I just don't want to waste time, so let's get started, and then we have a couple of more talks which is coming in. So let's get it started.
Okay, thanks, Vivek. Wonderful, everyone. Let's talk about Azure Container Apps. So we have this serverless month that's happening here at Microsoft, and we're all talking about serverless, platforms. And you probably would have heard about Azure Functions being the serverless offering from Microsoft, but there's also, which is one of my favorites, which is Azure Container Apps, which I'm going to talk about at Inland today. So my name is Nish. I work on the developer community. I'm a PM, and I work on various aspects of microservices development, enterprise guidances, and things like that. So one of my favorite things is Azure Container Apps. So we'll look at that, and let's get started. One of the things that we talk about is the app of the future is cloud native. So what it means is 50% of organizations will use applications built on managed services, including cloud native technologies by 2024. So what that means is that we are all rethinking how we're building applications for the cloud. The times then we used to build for applications, we used to build applications which were run on VMs or somewhere on the data centers and things like that, which were pretty easily approachable in certain form. Now we're thinking in terms of how do we make use of the cloud and the cloud infrastructure as a whole, right? So when we talk about cloud native development, why is it so important? Well, I mean, you probably would have seen about if you have used applications in the past, especially the enterprise ones and something like a financial ones. There used to be something called as downtime maintenance time. People used to say, okay, we are down between this time to this time, so please come back and visit later. Often we don't see that anymore, right? Because things have changed, because we want to run businesses 24/7, because your business may be running in one city, one country, to other geolocations and things like that too. So you want to scale faster, and you also want to achieve greater resiliency, which means now that your application is distributed in nature, you really want to be making sure that you are up and live most of the time, and that gives you credibility on your business, right? And also thinking in terms of how do you deliver apps faster, right? Now it's all about making sure your feature that you're building gets to your customers quicker. If there is a bug in production, that has to be fixed much faster. And you obviously have to secure your environments and protect your app and businesses and your customers too. Right now, when you start building cloud native applications for your businesses, when you look at Azure, there's a plethora of offerings out there, right? Obviously, we are talking about serverless today, so that's Azure Kubernetes Service, which is a managed Kubernetes. There's also Azure Functions, which is the most popular form of serverless that you would have heard already about. But Azure Container Apps went GA a few months ago, and we want to talk about that today, right? And obviously, there are other cloud native technologies like the managed databases. When you want to use a Cosmos DB, you want to have really high availability of your databases and things like that. And of course, when you look at Microsoft as a developer company, we build the best-in-class developer tools, which is Studio, VS Code, and other things. So you have those amazing technologies out there, including GitHub for CI/CD and things like that. And obviously security and community, they all are baked into, it's all part of the Azure. So you have the great strength to build amazing apps. Now, we've seen this. I mean, if you are like me, building apps for past 15 to 18 years, you on the left side, what you see is something which we have already been used to, which is like having a front end, a back end, and then there's a database, right? This is called the entire architecture, or also in some form, if it is constructed in a form where they're all packaged together, it is nothing but a monolithic application. Most often, you have the front end and back end together in a VM, and then you may have a database separately accessed by these services, right? Now, the challenge with that is, if you want to scale your application, you probably have to think in how are you going to scale this in a cloud environment. You will actually scale VMs, and the problem with that is you will go with heavy underutilization of resources, and also it becomes very, very heavy. Just give me 1 second. I see a lot of noise that's coming in, so I'm going to mute Vivek. Vivek, just come out of mute whenever you want to come back speaking. So I'm just going to mute you right now. Okay. So it feels good now. I hope. Okay, cool. All right, so that's about monolithic applications. And even though we used to build applications in a modular fashion, for example, you would split, let's take an e-commerce application, you probably would split it into an order, you split it into cart separately, you'll split it into customers and things like that. But they all were packaged together in a single deployable unit, and that is the key problem with this architecture for scalability, right? But then that's still, if you are someone who's still building applications like that, it may be great for your business. So it's not a comparison that this is better than the other. But when you really look at, if you want to make use of the cloud infrastructure, then you are looking at scaling up certain aspects of your application. And that's where there's 12-factor apps and other patterns that came in picture, and containers and other technologies kind of like boosted these things up, which is like, you can package your applications into an immutable unit, which is like take your code, your configurations, your deployable stuffs into a single image. And now those images can become containers when they're run, and they can be run independently. So you technically, if you look at on the right side, that's the microservices architecture that I was talking about. You design your applications, you break them down into based on business complexity, and then you create those services, like for example, orders, inventory, customers. Important aspect is they are separated by the database itself. So in a monolithic architecture, the single largest bottleneck to your application is the database itself, right? So everything is split into tables, so you have relations built up and things like that. But when it comes to microservices, you even go ahead and split the databases, and no two services can connect to each other's database, even if they want to connect, they can only connect via the services or service endpoints which the services expose. So that is the advantage that you get there. And with containerizations and things like that, you can scale independent aspect of those services. So whenever on a particular, say, a sale day, you can actually scale up all your payment services, your order services, and things like that, and your web endpoints, and separately than some of the services that you may not want to run it on a regular basis, or something on a sale day, definitely, right? So you have these advantages. So how do you take advantage of these, this new world of microservices is to start rethinking how you will build applications and make use of this cloud infrastructure, right? And let's talk about Azure Container Apps. I mean, Kubernetes has become the de facto standard, right? When you talk about microservices, people talk about Kubernetes and how you build applications to Kubernetes and things like that. When we speak to our customers, the biggest challenge that we felt from them is the pure, complexity that Kubernetes brings in, the learning curve that involves for developers, especially someone who's building applications. You're more now worried about the infrastructure. You're trying to understand the infrastructure code. You're going and learning a new, probably a language, a new understanding of how these VMs are managed, how there are nodes, how pods, and there's this huge amount of infrastructure related ones that you need to learn. And while this has to be in your DevOps pipeline and this has to go in that areas, if when you start programming itself, you start to have to think in terms of like how this is going to be built on Kubernetes and things like that, right? So that's why Azure Container App comes into picture, which is where you do not think about Kubernetes at all. Azure Container Apps is nothing but the serverless containers for microservices, which means, as the name says, it's serverless. So you don't worry about your infrastructure at all, but they are containerized, which means your application is still packaged in the way you would think of packaging them into wherever the containers are going to run, for example, Kubernetes. So Azure Container Apps is built on top of Kubernetes. It kind of abstracts away all those things Kubernetes brings in. You only think about writing your code, packaging them, and I'll show you how with some 2-3 simple lines of code you can actually deploy them into your Azure. And think of it like a platform as a service. So if you are someone who wants to get to Kubernetes, this may be your first step involved in packaging applications and not worry about infrastructure. And then whenever you're ready, that you want to have that fully managed Kubernetes, something like AKS, you can also extract it out and then go to AKS if you want to, right? Or if you're simple applications and services, all that you're looking at is like, I want to have an end-to-end communication between services. I want to have traffic management, or I want to scale on demand. These are the features that you're really looking at, not worrying about the infrastructure. Then Azure Container Apps is a great way to get started with. So I'll talk about a little more in depth about a few things. Like, for example, it's built for the modern apps on the open source technology. So it uses technologies like Envoy proxy for the ingress management. So one of the challenges at Kubernetes is to kind of like giving you putting an ingress in front and exposing them to the public, as well as for service to service communication, that is internal communications as well, right? So you add an ingress objects and things like that. Now here with Azure Container Apps, it comes with Envoy proxy by default. So when you deploy to Azure, you automatically get the ingress enabled, and then you get a link. You can decide if it is it's an internal or an external, and if you have a port that is being exposed, then you configure that. That's about it, and then you get those things configured by default, right? And it's also built on something called Dapr. Sorry, it's not built on Dapr. It provides you features for Dapr. So Dapr is a nice technology where you do one of the key things with microservices that you do service-to-service communication. And when you want to build service-to-service communication, there are multiple ways. You have a synchronous endpoint, so using HTTP or gRPC, or you may have an asynchronous endpoint, which is like using service buses, messaging queues, and things like that. So for the cloud, when you're thinking about resiliency. So one service is running, other service may be down for an interim period. So you are waiting for the other service to come. So you may be looking at, okay, let me do an event based, right? So based on services being available, it comes up and then it processes and it hands over to the next service, right? So when you think of those things, you're looking at all those, plumbing code that you need to write in your code. For example, if you are connecting to a messaging service, you need to write those plumbing code, right? So Dapr comes in a place where it takes up all these things and puts it something like a sidecar. So it uses a sidecar pattern, so which means it takes all these, networking infrastructure and other related stuff and puts it into a sidecar. So where you're only writing the configurations, and between your code, you're writing as if you're writing calling another DLL or another service that is where it exists, but it may be existing on somewhere else. You may be connecting to probably Azure Service Bus. You may be connecting to a Redis. You may be connecting to something else, Kafka. I don't know. I mean, so those things all comes in as a pluggable model, so you can make use of Dapr for achieving those things. So that way, you're not really worried about writing those infrastructure and other related codes. Basically, the code that actually kind of is necessary for you to connect to another service or anything else, but it is not something which you want to be focused on as a business. So those things get taken out and goes into the sidecar, right? So you have availability like that on with the Dapr. So that's what I was talking about in terms of infrastructure. You're not worried about those infrastructure aspects, and you don't particularly run a programming model. For example, if you look at other serverless offerings, you technically have to understand how these serverless are programmed, and your business logic kind of tends towards writing it in that pattern. But here with Azure Container Apps, it's your code. You, as long as it has a Docker file and it is an image, you can actually deploy to Azure Container App. So that means it is your own programming model. You can have a Node.js app, Python app, .NET app. They can all work with each other in a single infrastructure or in multiple as well, right? So you have those kind of advantages as well. And also, the important aspect of serverless is to scale on demand and also scale to zero. And the way we achieve that is using something called as KEDA, which is Kubernetes Event-Driven Autoscaling. It's a technology by which you, again, there are scale triggers. So you specify, if my CPU usage is at certain level, then you want to scale up or scale down or whatever, right? Or if my memory utilization is so much, then scale another VM or something like that, right? So you can define those things as a scale. It's very declarative, so it remains true to what you define there. So important aspect is you can scale down to zero, which means when you may have something called as a worker service, which is like, it's a background service. It doesn't have HTTP endpoints. It's just running behind the scenes, and it is looking at something outside. For example, it is looking at a storage queue, and if there is something in the storage queue, it needs to come up, do its task, and then go back to zero mode if you want to. So that way you can actually save some cost in terms of not running the applications when you don't need them, right? So you have these kind of advantages when you go with ACA. Now, important question that comes up is like, what can you build with Azure Container Apps? Azure Container Apps is very focused in terms of, very opinionated in terms of microservices building. So if you are someone who building microservices and doesn't need the complexity of Kubernetes, then ACA by default is the choice that you need to go, because you have the service-to-service communication with the help of Dapr. You also have the advantage of using revision management, which is you can have like multiple versions of your app when you want to do, let's say, blue green or A/B testings and things like that. You can also very easily achieve that using simple revision management. Like, for example, in this case, you can see that HTTP traffic, it can go to 80% on one revision and 20% on other revisions and things like that. And web apps, simple web apps that you're trying to host, that's great for using container apps, because it comes with all those custom domains, TLS certifications, and integrated authentication and things like that. And event-driven processing, I spoke about this. Like, if you are working with queues and things like that, ACA is a great service that you can look at. And also background processing. So we have something called as .NET Podcast, a sample that I will be showing out a little later, which covers most of these scenarios that we talk about. And that's the kind of scenarios where, if you're thinking about microservices development, those are really useful in those cases. Right. So we're going to look at the end-to-end demo, which is the .NET Podcast app. But before we go to the .NET Podcast app, I'll show you a very simple way how to get started with ACA, which is Azure Container Apps. And then .NET Podcast is basically the end-to-end demo. So it's nothing but it's just a podcast app, but it's open source. You can go and check the code on how it is implemented. It has Listen Together and other things in there. And importantly, let me show you quickly on the architecture it has. For example, it has a Maui app, a Blazor WASM app. So this is immaterial. We're not talking about any client apps today. But on your right, you can see that there is Azure Container Apps, which has the API. So we have a podcast API where all these client apps is going to query to understand what are the podcasts available, who subscribe to what. All this information is out here. We also have an endpoint where people can submit podcasts. So they can submit a new podcast, and then if it is a valid podcast, then that will show up on every user's app. To do that, what we do is instead of taking the podcast API and immediately doing the logic to find out whether it's a valid podcast or not, what we do is we ignore that and we directly put them into the Azure storage queue. And then there is a podcast ingestion service, which is a background service, which is actually configured in container apps with a scale set rule, where it looks at the storage queue and tries to see if there is anything in the queue that needs to be processed. It just wakes up and then it just processes and goes back to zero row, right? So you have that option of looking at and scaling depending on what is available. So that way you can see how these are all working together within the single environment, like podcast and like the API, which has the endpoint for the external traffic and ingestion and update. They are all worker services. They don't need endpoints, so they work within the same environment, but as a background services. Right. So I'm not going to go into the details of the rest of the things, but I'll briefly touch upon that when I will explain this in the demo. Now, but let's get started with how do you get started with Azure Container Apps, right? So before that, let's say if I want to go and deploy this, you can go to the docs container apps, and you can see that this is the doc that is available to get you started. So you start with an Azure CLI, you install that. You can also run it on Azure PowerShell. AZ login. So you log in with your Azure credential, and then the very next thing that you want to do is you want to add this extension called Container App, because everything that you want to do with Container App will depend on this extension. So you do AZ extension name and then Container App and add them. And once you do that, there's one more thing that you need to do on your Azure subscription is to register the Microsoft.app namespace. So that's where the Container App sits. So you need to register that namespaces and also operational insights because it uses log analytics. And then you provide some environmental variable like what is the resource group that you're working on, what is the location that you want to install, and then what is the environment name. Container app environment is something more like an environment in which all your container apps are going to reside. Within the same environment, the two container apps can talk to each other and they have the same networking infrastructure. But it's up to you. You can decide whether you want to have all the apps together in one environment or in a separate environment, depending on your business, right? And then you go ahead and create a resource group. Basically, these are the environmental variables that we created earlier, and we're just going and creating the resource group. And then if you go and say you want to create an environment, so that's the starting point, and you provide the location. Once you create the environment, you go ahead and create the Azure Container App, right? So AZ Container App, provide those input values. So your image may be different from this. So if you want your app to have an ingress, that means you want an endpoint. You can specify this here, and you should also specify the port. So if it's a HTTP endpoint, you probably are listening on 80, and then the ingress, you can decide between whether you want an internal ingress or an external ingress. So based on that, you will have the FQDN that is enabled for you. So you can access that domain automatically from outside if you say external, right? So this is a simple thing, but we're not going to do any of these things, and I'll show you how I can achieve the same thing without doing any of these things. So right now I have a Node.js application here. Just for the simplicity's sake, I'm just going to use Node, but we're going to look at .NET as well in a bit. So I'm going to open that in VS Code now. So you can see that it's a simple Node.js application. It has a app.js file. And what I want to show you is it has something called as album controller.js. So it is looking at so if you do /albums, it is going to pick up the album.js. It's all nothing but a simple data. Think of it like something comes from the database, and it is going to drop it into the user's endpoint, right? So for example, if this is an endpoint, and then when you query the album, it just dumps in this data as in the response stream. It's a very simple one. All that I have here is just the Docker file, which tells that, okay, this is a Node.js application, and it exposes endpoint like 3,500. So this is what it needs to listen on, right? So that's all it has, right? So once you have that much in your code, I can now go here and type in Azure Container App. Let's see if this, okay. So let's use help here. So I can show you some of the commands that's available here. There you go. So I have Azure Container App. I can do auth if I want Dapr related ones. If I want to do ingress, I have ingress related commands. And what I want to do is something called as up command. Just is similar to the Docker Compose app and things like that. That you basically want to bring this up into deploy it and then bring that services up, right? So that's what I'm going to do. So I'm going to use AZ Container App. Just going to look at the questions if there's any. Okay, a few. Cool. Oh yeah, so Nilesh says Nish has some RGB lights. Yes, that's happening there. It's fun to have some RGB lights in your office. Okay, so let's do that. AZ Container App. So the way I do that is AZ Container App, and then I use the up command. I'm just trying to see what's the best way to display this so that I can. Come on. Yeah, so this is AZ Container. If I correctly type it. Container App, up command, and then I provide a name. So in this case, I'll just say happy hours. That's my name. And then I want to say that, hey, I want to build up the deploy this based on the source code here. So I just provide my source is right here. So I just say hyphen source and then dot. So that's the current directory. And that's it. I'm just going to hit return key. And you can see that it automatically looked at the Docker file and said, oh, there's a port 3500. So that's what it needs to, expose. And then you can see that it was actually, it went ahead and used my existing podcast RG resource group, which is where the .NET podcast is what I've installed it. And I have a very good reason to tell you why I'm using that, but in a bit. So you can see that it is also reusing the existing environment that is already there in this resource group. It's going ahead and building the Docker image, and it's not building here. It is my Docker. There's no Docker running on my desktop right now. So it's actually building right inside the container registry. And then it is going to be pushed into the container registry as well. So you can see that it is going ahead and pulling the few things. It's actually created the ACR for me, and it has put in something called as happy hours, tagged itself into some random number. And then you can see that, it just went ahead and trying to push into the ACR, which is all done. Now it's trying to make a run. So that means it did all these things by itself. So I can promise you all that I did is AZ login and AZ container app registration. Adding that extension, and that's it. Just pointed to my code and then did AZ container app up. And the reason I did not explain anything else in that Node.js app is because I do not know much about Node.js, but I just took it as a sample, and I wanted to execute it and see how fast can I get to code to cloud. There you go. So was pretty easy for me to just get there. Now, as soon as it is done, you can see that there's an URL also enabled for you. So that means because ingress is true on that. So if I click on this, so right now it's on my this desktop here. Okay, there you go. So happy -hours, and then it just created some random name. It says it doesn't have albums, so we'll give albums an endpoint, and there you go. So that's it. So within no time, I was able to take my code and then deploy to cloud. And you can see that it's actually running on Kubernetes, and there's none of the Kubernetes things that we brought in here. There's no Helm charts, there's no deployment YAMLs, there's none of that, right? And all that is, or if you go into this, into the podcast RG, and the reason why I want to tell you this here is this is my existing infrastructure where my .NET podcast app is running. For example, if I go into podcast web here, right here, let's go into the URL that it exposes, which I don't remember right now, and I'm expecting the portal to tell me in a bit. There you go. So if I open this, and while that's happening, I can go back to the resource group. So there you go. So this is a .NET podcast app, and if I click on sign in, it is actually going in. This is the Blazor hybrid app, which is running inside the browser. It's a Blazor WASM, so I can go and listen to my podcast. So this is all running in Azure in Podcast RG. So this is my container apps environment, and you can see that. So if you go, this is the end.podcast environment. That's where it went to deploy. This is completely .NET apps. So all of them, what you see here, they're all .NET apps. So it has a web app, there's an ACA, but within the same environment, I went ahead and installed a Node.js app itself. All right, so I'm going to refresh this. Let's go search for happy hours. There you go. So they right here. So this is the happy hours app. Now you can see that this is nothing but a container apps app. So if I go into scale, I can also specify the scale for this right here. So I can see, you can see that minimum replica is 0 to 30. It's all by default. So I can edit and I can create a new version if I want to. And I can provide those details like what is my scale and other things. Or I can provide it in the CI/CD pipeline, but which is the right way to do it. But I just want to show you that it's all possible here. So if you go to containers, let's see what's in the containers. So you can see the container registry from which the app was pulled in. It's using the Linux and variables, help props. If I have defined it, it would be here. So you have all of that right inside here, right? You can go into Dapr. If I want to enable Dapr, I can also enable Dapr from right here. Okay, so it's pretty simple. So they all are, again, if you look at this one right here, podcast ACA, API podcast API CA. So now this one, if you look at, this is all happening. This is a .NET app, and you can see that it has the same level of configurations that is there here. So if I go to the scale over here, let's see if the scale is again 0 to 30. So those are all default. Let me see if I have a scale that is configured for ingestion, which I think I have. And if I go to data CA and scale, let's see. Not sure. No, I don't think this is either. All right, that's fine. I'm just trying to see if there's anything else. Okay, there's no ingestion service here. That's not deployed here. That's the reason why it doesn't have there. Cool. No worries. So what I'm going to show you is, let me show you now an end-to-end way of deploying this from Visual Studio for .NET Apps, because you have all these things that I showed you in CLI all baked into Visual Studio itself, and we'll see an end-to-end how to do that. So let me go ahead and play a video, because I recorded this in advance, because with ACA and generally anything to do with cloud, you need to wait for a long time for its deployment to succeed, and to demo that, it's even harder. So what I did is I went ahead and pre-recorded this demo. So I'm going to play that for you right now, and then we'll come back, take questions from you. Podcast API backend in Visual Studio. Create a new project, choose ASP.NET Core Web API, provide a name, and make sure to check the Docker support in it. And then click create, and this will give a default web API project. And because it has Docker file in it, the Visual Studio detects that Docker was not running, so it goes ahead and starts Docker Desktop. Take a bit of time, but then it just goes and builds the images, and then now we're ready to go. The project by default gives me a weather forecast endpoint, so I'm going to change that to something like categories, which may be relevant to the podcast API. I'm going to leave the implementation as is, because I'm just going to create as a sample, but I also going to create another endpoint, which is called shows, and I can just remove those weather forecast implementation there, and I'm just simply going to return a string. Probably I'm going to write return all episodes, or maybe I can just type return shows, which is great. Now I have two endpoints. I'm going to change the name as well, and I'm going to run this in Docker. When I do run, you can see that I have by default, I get the Swagger endpoint. So I have categories and shows right there. I can expand it and execute, and you can see the response has shows in it. Now let's go and publish this in Azure. So if you right click and publish, you get this menu, and you can choose Azure here. You can also choose Docker Container Registry if you're just simply creating an image. Now here I'm going to choose Azure Container Apps. You see preview, but it's now GA, but I'm going to choose that and click next. Now this one gives me to select container apps. I'm going to create a new one. I'm going to create a name. It creates an environment. It provides resource groups and other things. Make sure you select the right ones, and then click create. Now this will go ahead and create the environment for me. The one more step over here is to create the registry as well, so that you want to keep it in a secure registry, the images that you create. So I'll just choose mine, which is already there, which is the Nish demos. So I'll go ahead and click finish, and now you can see it already created an endpoint for me, ingress, with including HTTPS there, and that comes free for with Azure Container Apps, right? I can go and choose Swagger to see. All right, there's nothing there. Now I need to publish, because that's when my image is going to be picked up by Container Apps, right? So I do that, and now let's go see what's the response. Now if I go do Swagger, I should be getting the same thing that we saw earlier. That's it. Categories and shows right there. So far, this source code is on my local, so I can go ahead and add to my source control. I'm going to choose GitHub. You can choose Azure DevOps if you want to, but I'll add in GitHub credentials here so that I can publish this repository into my GitHub. So I'm going to enter my details there and also change a few things like let's go ahead and change the name, repository name to podcast-API instead of dot. And I'll leave that to be a private repository for now, but you can go ahead and change it if you want to. Create and push. So this will take care of taking my source code and publishing it there. Now, if I do a publish again, it asks me for registry. That's okay because I have it. Now look at this. It has CI/CD option as well. So instead of publishing directly to Azure, I can choose this option. What it is going to do, it's going to create a CI/CD pipeline as well for me. And this is all Visual Studio doing all the amazing things that it can do, right? So now it says whatever you go change, and then if it's push, then it is going to go and deploy as well. So just to see this working, what I'm going to do is I'm going to change the endpoint, or I'm going to add the endpoint. We call this as episodes, and then simply let's call it as episodes. Let me type it right. That's it. And then commit the changes as always. Now, if I say commit all, and then the next step is syncing. So I'll go ahead and sync this repository. So now my local and my remote is synced. So I'll go back to check. So I'll log into my GitHub, and in this case, just directly go into my repositories. Forgot the name that I gave, so I'll go to the repositories and then search for it. I think, yeah, that's podcast API test. So I'm going to click on that, and there you go. You can see that, it's already running. So that means the workflow is all set up for me. And this is all done by Visual Studio. I did not even type all these things in, right? So you can go and change it if you want to. So there's also code there. So there you go. It's built and deployed to container registry, and then it is going to pull into container apps as well. So if I refresh, there you go. So now I have the new endpoint set up. So you can see how CI/CD entire pipeline is also set up for me. Now let's take a look at .NET Podcast app, which you can find on github.com/Microsoft.NET-podcast. Now this is a simple podcast app which has a .NET MAUI front end, which connects iOS, Android, Windows, and Mac, and also has scalable backend, which includes Azure Container Apps. If you look at the architecture of .NET Podcast, it has the .NET MAUI frontend, which means it has iOS, Android, macOS, and Windows application. It also has a hybrid app baked into it, which uses Blazor. That's the listen together one. We'll see that in a bit. Now, if you look at the backend, it has Azure App Services. Now, this is great. It has a couple of things: Podcast API, Podcast Ingestion, Podcast Worker. Well, Podcast API is just nothing but the web API endpoint, which we saw earlier. And Podcast Ingestion and Worker, they're all background services. They are running behind the scenes to particularly looking at some functionality. So in this case, let's take an example. Like if someone wants to submit a podcast, they can access the Podcast API and submit the podcast with certain information. But now all the podcast that is submitted shouldn't be going into our database. So what we do is we send it to an Azure storage account. It's into the feed queue. And there, Podcast Ingestion Service is actually going to look at it, and it is going to process them. And if it is relevant to this .NET podcast, it is going to pick that up and then send it to the SQL Server database. Now, there's also Log Analytics Workspace. This all comes within the Azure Container Apps. We also have SignalR for doing listen together, which is really amazing. That is when you want to share a particular podcast with somebody else and then want to react and respond to certain things that are spoken there. We use SignalR and show you how to do that, including the Blazor WASM there. Finally, this is a great architecture to see how to build a simple podcast app. If you open this podcast app in Visual Studio, you'll see a Docker Compose file, which is a great way to run multiple applications within the containers locally. Now you can send some environment variables here, but that's all. I'm not going to get into the details of these, but let's look at how to run this, right? So if you go to Docker Compose, you can run it, but I want to show you these Docker Compose launch settings where you can choose which ones you really want to debug, and the other ones you can just simply say you do not want to debug, so that way you're only working with the services that you absolutely need to debug. Now I'll go ahead and run this all together. So it's going to boot up everything. It's going to build all the images, and there you go. So now I have the Podcast API endpoint, which is with all the feeds and other things where you can submit a new podcast, or you can also query for podcasts, which is already in there in the database. I can also go to 5001, which is a listen together hub. It's a SignalR service. And I have 5002, which is the podcast website. And now this is a web page. And if you click sign in, now this is a Blazor app. If you go in, you can see that the ones that I've subscribed to, and I can start playing. You may not be able to listen to the music. I'm able to hear here. I can modify a few things like increasing the speed and things like that. It's accessing these APIs for running the soundtrack onto the audio channels, right? So now if I go to the listen together mode, this is very, very exciting for me. If you see, I can create a new room so that I can invite others to join. So here I'm going to give my name as Nish and start opening the room. So now I have the invite code or the copy code. Now I can send this to somebody else. Now, because while recording this, I don't have another person here, so I'm going to use a new private window and open the same URL. And now I'm a new person here. And if I go to the listen together mode, I can join the room using the code that was created there. So if you'd see, that's the code that we created. If I copy paste that and say join the room, now I can give Matt as another user here. I'm just going to show you an example. So I'm going to go side by side. You can see the dark theme and the bright theme. And if I play here, you can see on the right, that also plays. And I can also send my reactions, so for certain things that's being spoken there. So that way you can see how two apps are connected and it is able to react and respond to things. This is all the magic of Signal R. And if you are excited about doing this, something like a chat app, you can go ahead and take a look at the source code and implement something for yourself. Now, what I did not show you today is executing the .NET MAUI app, which you can also try it for yourself. If you go into that podcast app, there is a folder where you can execute the MAUI apps. You can make sure that you have MAUI workloads so that you can run this locally. You can also debug them locally or connect to the remote services. They're all going to work great. Just go to the .NET Podcast GitHub repository and it has all the instructions to get you started. What I love about this architecture is that we are using Azure Container Apps as the mobile backend. The good thing about that is it obviously supports the auto scalability feature, which is what we are going to look at it right now. And the other thing is it can scale down to 0, which means you can save some cost too. So this is all done using KEDA. So we're not going to go into the details of it, but I'm going to show you in .NET Podcast how we managed to use this feature. Remember I told you there's a feed queue where every podcast that has been submitted goes in, and let's see how that podcast ingestion service is scaled. Now, in this case, what I'm going to do is I'm going to show you the ARM template where we write the details of podcast container apps. Within the container apps configuration, we kind of like provide the details of we need an ingress, which that means we need to expose it externally. And then we have a few things that we can set it up here, which is one of the things is the scalability factor, which I was talking to you about. So right now there's a min replica is 1, max replica is 5. That means based on the scalable rule that we set here, in this case, HTTP scaling, that means if you have 20 concurrent requests or more, then Container Apps is going to scale your apps automatically. And the good thing is if you set min replica to 0, you can also scale down to 0 when there is absolutely no traffic as well. If you look at the ingestion service, we set the min replica to be 0 and the max replicas to be 5, which makes sense for this service. If you look at the scalability rule here, we are looking at the feed queue, which is the storage queue, which I was talking about. So if we have really a lot of queues of podcasts coming in, and that's when we want to scale. So depending on the queue length, we scale to maximum of 5 replicas, and that is going to go ahead and process those new podcasts that is coming in and ingest into the database. To see this in action, what I'm going to do is I'm going to create a simple script that is going to send in a lot of new podcasts into the service. So here we go. So I have something called a simulate-feed-request.ps1, and I'm hitting those URLs, which is nothing but the podcast API web point. And on the top left, you can see the message count going up to 57, 50. And on the right and left, those are the replicas. One is the web API on the top, and the bottom is the worker. And now I'm again hitting more so that, we can see the scalability, and you can see that on the top, based on the web scaling rule, there are 2 replicas now. And in the bottom, there is this worker, which is now increased to 3 replicas. Now that is so cool that it automatically is able to do that. Now, if you look at the workers, look at the handler part of it, all that it is doing here is basically this worker is going to be initiated. This is a fairly simple one. All that it is doing is looking for the .NET keyword in its title and accepting it. So based on certain configurations, we were able to scale up as and when there is demand. All right, now let's go look at the portal on how this has been configured. So see, these are the things that gets defaultly configured. And if I go into the podcast API CA, which is container apps, and if I wait for a little bit of say time, you'll see the URLs and things like that come up there. So that's the URL which it's being hosting the API. Now, if I go to the Dapr, if I have to enable Dapr, I can go ahead and do that. But for this demo, I am not using Dapr, so I've disabled it. I can go into the containers or scale, for example, and see what is the configuration. So if I have to do this in Portal, I can also go ahead and do that. But I think it's better to do it in the in your ARM templates, and CI/CD takes care of everything that way, right? Cool. This is the ingress where the external traffic has been enabled or disabled. It's a pretty cool demo, so I hope you liked it. All right. So that's it, Vivek, from me on Container Apps. I hope you all enjoy the demo. And it's just super hard work to kind of like record them and wait for it, and then edit it out, all the time gaps, and then put some voiceovers to it.
Definitely, I think it's very difficult to record. I know that. We know as developer advocates, we know how difficult it is to record a demo like this.
Right.
So, Nish, there are a couple of questions. There are questions in the from online audience as well, and there are questions in the uh, from the audience here as well.
Okay.
So, first we will answer the online audience questions. So, Nish, you have the control anyways, so you can pick the questions from online, and whichever you want to address, and see
Yeah,
how
I'll
you
pick the
can.
easy one. I'll pick some easy ones. Will the recording will be available? Yes, the recording is available on the same link right now on YouTube. And there's a question on this. What are some subtasks within domain of monitoring, if that is applicable in Microservice app? In a microservice app, I mean, generally in monitoring, there is like multiple things. Like one is, yeah, obviously logs. You want to do some structured logging, which means you can query the logs easily. You want to enable distributed tracing, which means you need to provide correlation IDs between the services so that it connects to all. Whenever you look at the log, you know that there's an entire trace available for you to understand from which point it started and how it transmitted through other services and what was exact exceptions and errors and things like that, right? So there are a few other things like that which I don't recall right now, but yeah, there anything that comes under the monitoring and instrumentation side of things, you probably want to take a look at that one. What else? Um, well, and okay, there's a question on most of the time SignalR loses connection when app goes background. How do we ensure? Yeah, so SignalR depends on the WebRTC. So whatever things like drawbacks there would apply there as well. I mean, the way we can work around with this is like combine this with push notifications, like for the platform which you're building apps to, and then you will be able to notify the user when there is some messages. So just like every chat app nowadays that does it, like it waits for a few time when people are not responded it, then sends a push notification about the depending on the sensitivity of the messages in the configuration that the user has configured for notification settings. So you can decide to send a push notification instead. I don't see anything else, which is I see turn all text in program into Chinese or Japanese language. Yeah, feel free to. I mean, if you were talking about the demo app, feel free to send us a PR. And I don't know who's going to verify this, but probably one way to maintain is like maintain a version of it, and then we probably can send links to that.
Yeah. So there are questions from the audience here in person as well.
Sure.
So
My question relates to the CLI command it used for the Dapr, setting up the container app. So, for example, if I deploy with some name, and is there functionality to upgrade when I change the code? For example, maybe I change whatever files there are, and then I do the same thing up. Like I use the up command, but again upgrade flag with it. Or if I use the same name, does it automatically create a new image or?
Yeah. So I'm trying to simplify the question to you, Nish. So the question is the CLI which you used for deploying this container apps. So he wants to see if there is a code change which you make, and is there a easier way to just upgrade it? Is there just I can type in some up command or upgrade command or something like that. Is there any command such in container apps
Yeah.
where I can update the code?
So same command will work, but there's also another way to do that is use the CI/CD. All right, the way which I did it, like set up the CI/CD for it, and then so it just becomes easy. From CLI itself, you didn't even have to have source code locally. You have this option called hyphen repository, and then you can config tell that URL for that repository, and I think it opens up a browser and allows you to authenticate to kind of like get you the credential to do the GitHub, and then it will do the CI/CD for you for that repo as well. So that's also one way to look at it. I mean, that would be the easiest way, I would say. Like then after that, it just once it is set up, it's just about you changing the code and then committing the changes and then seeing it going live. Did I answer your question?
Yep.
Okay, cool.
So yeah, one more question.
So I have an app which I have built. It's started. So it's just that I have not used Azure. So can somebody from this team, Microsoft team, help me to put it up along with the container in the Microsoft Azure cloud? Is there any help somebody can give me there?
Yeah, so I'll take this question, Nish. So basically,
You
this
want to
question
repeat
is
the
around,
question for the online
oh
audience
yeah. So
because
the question
we
is
couldn't hear anything.
around the startup and how to bring that startup onto the Microsoft program, and he needs help in doing that. So we will discuss that after the session, after all the sessions.
Basically, it's all the simple thing. It's just that I have the app ready. It's running on my laptop. I just want to push it on the code.
Yeah.
I have no idea what to do.
Sure, definitely. We can discuss that
Plus
after the
also, I
session.
need to know what the other features Azure gives. Like I'm sure Azure has a lot of analytics and a lot of other things.
True. Definitely, we can have a discussion after the session on that. So I think Nish, we are done with the questions, or we still have the question here. Just 1 second. We still have the question.
Okay.
Yeah.
I just want to know if you can use the cognitive services with the Azure Container Safety.
So there is a question on, can we use Azure cognitive services with the container apps? I think you can.
Yeah, absolutely. I think there's nothing stopping you from using any service, regardless of whether it's Azure or outside, as long as they are reachable from your service where you're deploying it. It should be good.
So you could use it with SDKs or as APIs and containerize it, and even cognitive services nowadays support containers as well. So you can do that. Yeah, one more last question.
Yeah, I want to like if I want to set up an app like Uber using Azure, and is it how much time will it take? Is it like without no code can I do it using better app? Is it like possible to do it?
So the question is, Nish, how to build Uber kind of an application, and how much time does it take to build such an application into the system? So that's a very relative question. So we can obviously discuss after this session. We both can have discussions on the same after this session on what exactly you're looking for, because it takes ages to build such apps, right? So it is built on various things at the back end.
What is the timeline? I don't want to because if I want to scale the fast, Azure should help me to scale it fast.
So yeah, quickly, I'll just tell you. I mean, I'm not going to talk about the architectural stuffs, but I think that's where you want to look at something like a serverless offerings, where you do not want to waste time looking at infrastructure and other aspects and build those learning curves. Instead, you look at these options where you are more quickly to get your POCs or proof of concepts that you're building to the cloud, and then you take the advantage of those scalability and other aspects, which is why you would come to cloud: the security, scalability, resiliency, performance efficiency, and all those things. So make sure you use these kind of things so you can give faster than the regular way of doing things.
True. Got it.
I have just one last question.
Yeah, last
So
question.
generally, I code injected a notebook. I do all the stuff there. So will it be possible to take that code and use Azure Container Apps and put my artificial intelligence, machine learning code into this Azure Containers but in cloud?
Yeah, we can do that. I'll tell you how to do it after the session as well, because it's not relevant to the container apps, but it is more of building that whole pipeline and deploying that pipeline as an API and using that API into your containers will work, right? So we'll obviously discuss those things once we are done with the sessions. I'll be here. We can obviously have a one-on-one meetings on that. Okay, thank you, Nish. I think we'll just move forward to the next set of sessions. I think we have bunch of things to cover today, and thanks again, Nish.
Thank you so much. Thank you for great questions and being a great audience. I'll see you next time. Bye.
Yep. So yeah, we are moving on. So basically, so I'm going to take the second session on the serverless part of it. So how many of you are familiar with Azure functions? You have done it. You're done first set of functions before you built it. Great. And we have a couple of them who are new as well, and there are people in online as well who will be new. So we're going to talk about what is functions, what is serverless as well. That's the major thing, and then we're going to see some demos and other things and some use cases as well. I will end the session with use cases so that you can go back and build something out of this, right? And before that, I just want to introduce myself. I've been saying hi, hello, welcome to my show and other stuff. But yeah, I'm Vivek. Um, I started my career as a software developer at IBM. Did a couple of things from a DevOps perspective, and I was also the co-founder of Nudonext Technology. And after that, I was very much interested in communities, working with developers, working with startups and everything. So joined DigitalOcean as a developer advocate, and this is my second role at Microsoft. My first role is being part of the strategy and investment role, and the second role is in the cloud and AI engineering. Back to engineering, by the way, if I have to call it. So that's me. And if you want to get connected with me, these are my digital coordinates. Whenever you want something, you want to learn something new, just connect with me from a connection perspective. So let's just start with the history. So what I'm talking here is it's about history. So you can guess my age because I'm part of that era where we were doing everything on premises, right? We had server rooms. We were wearing jackets. Nowadays, we nobody wears jacket while you're working on computers, but we used to wear jackets even when it was like summer. We were wearing jackets and going into some of the server rooms and sitting in those rooms and working on those big machines which were there, right? So I'm basically from the on-premises era, and obviously the digital transformation took place. There were a couple of companies we started moving towards solving the problem of going into the rooms instead, moving out of those rooms and managing those machines and everything through a different set of tools. And that is where the infrastructure as a service came in. Obviously it was built on the security part of it, right? And then managing the OS and other tools became very important, and that's how PaaS came into picture. Like, for example, managing a database was so difficult from an on-premises perspective, right? So it all moved to a PaaS. It was easy to manage there, but still there were challenges. And how we solve these challenges, moving the business logic into serverless, right? Moving everything on onto the onto the cloud providers, and you are just focused on business logic which you have. So that is what serverless is all about. So that's basic. And I'll also talk about, as I talked about history, there were problems right before cloud. If you see this, there are a bunch of questions, when we need to procure machines. We don't know who is going to monitor connections. and power issues. We need to make sure power is up and running, backups have been taken, patches have been done. All of these things were there before cloud. And when digital transformation happened, when we moved into again infrastructure as a service, there are a bunch of questions still remained, but it solved some problems for us, right? So if you see, there is again backup problems and patching problems, and choosing an OS is a problem, and size of the machines, and how do we scale is app is again a problem, right? It's not easy. And even in infrastructure as a service, you just need to have load balancers, have different machines on top of that, and all those things. And then came the era of PaaS, which is again the questions, number of questions reduced here, right? If you see the slide, the questions reduced, but still there were questions. The patching system, or the size of the machines you're going to run on, and on obviously scaling your app is also was a challenge when this happened. And then came the serverless, where you're just focused on building app. You don't care about how this scales. You are not worried about security part of it, maintainability, everything, right? So that is what serverless is all about. And so what is serverless? So a couple of things. It abstracts the infrastructure for the developer. It's basically abstracting the whole thing for the developer is only focused on his business logic. Rest is everything is managed by the cloud provider. When I say rest is everything, it's the infrastructure. So when I say infrastructure, what it is, it's reliability, security, scalability, everything is and availability as well. Everything is managed by the uh, cloud provider, and wherever you're hosting these things. And most importantly, all of these things are event driven. There is an event which is happening, then it gets triggered. So what does that mean? That means it's very simple. You're only paying pay per use, right? It's very simple example. If I have to give you, we all use the UPI transactions, right? So I don't think so anybody is doing a UPI transaction at 1 a.m., 2 a.m. Like it's very minimal. So we don't need to have an infrastructure for that, right? If you have these transactions which is happening on serverless, running on serverless, the cost would drastically reduce, because there is a time period within your application where nobody is going to use our service. While I was in Blackbird, none of the orders used to come after 7 a.m., because all lorries and other things used to start working after and before 7 a.m. Like they used to start at 3 a.m., the logging and everything. And after 7 a.m., there is not much traffic into your application. And then again, some traffic which is going to come in. And then again, there is a little bit of traffic which is coming in the evening. There's a bunch of traffic which comes in the evening. So there is a time period within your application where there is no need of infrastructure at all. You just need only on a need basis. So that is where serverless is an amazing an amazing service, and it's a concept to use, right? Where you have a minimal use of it, and you have an event. Basically, somebody is doing a UPI transaction, somebody is booking a car, somebody is booking a lorry. So there is an event which is happening, and then it gets triggered. So unless and until somebody is not doing it, you don't have to pay for the infrastructure, right? So that is the main purpose of it, and that is what serverless is. And there are a bunch of benefits to it. Obviously, you will only focus on building it, and you are not really focusing on managing the infrastructure. We all know, right? I come from DevOps background. When you see managing the infrastructure, scaling the infrastructure, making sure it is available, it's all time consuming and very difficult. And in your large scale scenarios, it's much harder. And obviously efficiency, right? You're focused on getting your app into the market, and also you build quality in your production, right? So there is all the availability, maintainability, security, everything is, and performance, everything is built into the system. So you are only just writing app and deploying this app. So that is where the efficiency also comes in, and the flexibility. When I talk about flexibility, it's more important here. The You can code in different languages, the serverless supports different languages. There's a Java support, there's a Python support, there's a Node.js, there's a .NET. So your team can be diverse, and you can build systems around the best solution, right? Say for example, Java might be very good for solving certain problem, and .NET might be the good option for building certain problems, right? So you're going to use both of these uh, code bases in your application. That is where the flexibility comes in, and this is a very good fit for microservices. And Nish did talk about the monolithic and the microservice, and this is an amazing tool for building microservices, right? You can have bunch of services doing one specific job and solving the problem, and you connect all of these things to an app, and you're using this as part of an app, right? So that's a simple way to build it. Excuse me. So so functions as a service was came into the picture, and functions as a service is nothing but a programming model. So it's basically framework. It's kind of a platform built, and it's a framework built on how to build this service. As a developer, how you can focus on business logic and deploy it as a function, right? Function is what you if you come from background of coding, right? So function is nothing but a single piece of code. It just do a single job, right? You write functions, different functions, to solve one single piece of things. So that is why it is named as functions. So basically this does only one single specific job, and whenever that gets triggered, it runs and executes, and it provides the data or pushes the data into different services, and it just closes its execution. So that's what I mean by single responsibility there. And what is short lived? So basically, this is, as I told you, right, it's just short lived, right? It is basically running in the background. Event happens, it runs in the background, closes the section, closes the event, right? That is what excuse me. So there is, it's also stateless. Basically you don't attach a state to this. Basically you are going to run it as per the execution. So there is no state to it, there is no data associated to it. It is just app application running. I'm sorry, I'm having a bad. Okay, so there is a state, and then I don't know, something wrong. And then there is a event based. Again, this is again an event based. So obviously it is scalable. Since there is no data attached to it, it is obviously scalable. You can replicate it. So if you attach a data to it, you can't replicate. If it is no data attached, you can just use it as a single point. You can still build stateless with durable functions, right? And that is also available. It's called as durable functions. I'm not going to talk about it much because of the time, but we will obviously can discuss what are those things. If you have a specific questions, we can have a discussion on that. So functions is very simple. It is a programming model. As I told you, it is a structure how you can build a function, and you can deploy a function. And there are a couple of built-in things which is available, which is triggers and bindings. Bindings are obviously you can bind input and you can bind outputs. So that is one thing. But there is triggers. You need to have different triggers are there. It could be the event can be executed with HTTP trigger, or it can be executed with data getting into a blob storage. Something happens on a storage and it gets triggered, and or it can be through a Cosmos DB where database is there and something happens on the storage and it executes, right? So that is also be done. And obviously, as I told you, it's about developer experience. You can test locally, you can test it on Azure when you deploy it as well. So basically when you build application, you can test it locally. This particular structure, this particular uh, whole programming model gives you that flexibility to test this application locally. I'll show you how to do it, and while I'm doing the demo as well. And obviously there is different hosting options which you have, which you can take. So ultimately what I'm talking about is, you're only focused on code. You're not really doing the plumbing job, which means managing the infrastructure. So there is um, no infrastructure management here. You're only focused there on your code, and it auto scales, it scales, and and the workload increases, still scales, and it replicates. You can actually set, basically you can say I am going to scale from 1 to 30 or 40 replications. All this is possible, and your code can be scaled too fast as well. And again, you are not wasting money. That is the biggest thing, right? You are only spending money on the usage, and how many people are using your app, right? The best suited for startup. And how it is uh, developed. So there is a trigger which I talked about. There's a simple trigger which is, it could be HTTP, it could be a Cosmos DB update, it could be a storage update, it could be a queue update, anything. And then there is input and output binding. When I say input binding, it could be binded to different storages, or it can be binded to different set of structures which is there. And output binding, what I mean is how this can be you know can be used. The data which is coming out of this can be used in different services. So there is a different services which can be part of the output binding, and that is the structure here. um, so let's go and try and build an application. And I was testing this today morning as well. If somebody are following me on Twitter, so you would see this right? So let's go and see how exactly this works. So even before I, sorry, no, I mean this code is available everywhere, so no worries. Let me show you where you can find. Okay, so I have um, I have installed couple of things. Okay, so there is Azure extension on my Visual Studio Code. There is function extension already installed, and there is something called as Azure Functions Code Tools for CLI. So it is also been installed on the extension, right? As part of the extension. So it is all setup is ready here. So I'm not doing anything specific. So let me show you how to get started. So if you see here, let me close this off, and then we'll come back here. So if you see this, so basically once you install, you can see this function app here, right? There's something called as functions, and then there is something called as workspace. So in the workspace, if you go here and click on this button, you can see create function, right? So through Visual Studio, you can just click on the create function. Obviously you can do this via Azure portal, and there is CLI as well, support is there. So I'm just doing it through this tool, right? So when I create function, it will show me all the triggers which I'm going to use. So you can see the triggers. So here are the bunch of triggers. So if you see, there's blob storage trigger, and as I was telling, there is bunch of triggers, right? The event has to be triggered from somewhere. So either HTTP, or it can be time trigger. It is nothing but a cron job kind of a thing, and it can be a grid, it can be queue, it can be service bus. So bunch of things are available, so you can pick and choose whichever you want to use. And once you choose this, all you need is provide the name, and then just get started with it, right? So once you give the name, it will create the service, right? So I'm not doing that because of the time, interest of the time. um, I've already created one service there, which is Wikibytes. You can see that. So that is my local. So the code is local. I mean, I've created the function in the local environment. That means it is still on my laptop. It has not been shared across to the deployed to the cloud. Okay, so you can see this, and when you create, you'll see the code like this. And by the way, it depends on which programming language you have chosen while creating the workspace. So the programming language I have chosen is Python. So that is the reason why it has given me a structure for Python. So you can see that there is requirement.txt. If you create a Node.js, it will give you package.json, right? And if you create something else, it gives different structure. So there are a bunch of things. So because I have used Python for the workspace, it is using the Python structure template. So as a developer, you already have the template, right? So when you go and create a function on whichever programming language you're familiar with, you just go and create, and it just gives you a simple structure, right? So now you can see that um, code is there, and this will be a default. There will be a default code, obviously, where you can test it out. But I have added some code there where I want to tweet from here, so it is there. And what is the thing which we'll add here to tweet? Anyone? What I need to add here? Let's tweet from here. Huh? Yeah. Hello everyone from hello everyone. Tell me. Any options online? What we should tweet? Huh? No. Let's do this. Hello everyone. Welcome to Azure. Yes. Okay. Let's tweet this. So now I have the code. So the code is written very simple. I mean, uh, if you go to requirement.php, txt, I've added two things. Uh, you can see tweep and Python deep couple are the modules which is there. So you can use those modules, and obviously you can figure it out. And so I saw a couple of them were asking for code from me. This is something which I have not written. It is already there. It's, if you go to tweep, how to use it, you can use it. So there is nothing brahmastra about it. Okay. Okay, so let me change this view to okay. Cool. So the code is basically doing nothing. It's basically taking name and it is printing the name and other things. But I've added a tweet to it. So whenever I run this, it also runs a tweet. Uh, it posts a tweet on my uh, Twitter handle. Okay. So here I've used all the Twitter keys and other things. Obviously, you can't see my key, right? There is a reason, because I'm using something called as decouple, right? I'm using a module called as decouple there, so that I can hide my keys. Otherwise, everybody will start posting through my Twitter handle, right? So I've used that key. So that's the thing. So basically, we are good to go. So now the code is written, the structure is ready, and everything is ready. You're ready to go. You have the code, you have everything. So all you need to do is go back to Azure extension, and you have the functions created. So you can just go here and right click, create a function. So if you see this, you can just go and create function app in Azure, right? So you can just click on that and it gets created. So you need to off. Okay, just a minute. It's okay. So there is click. You just need to click it. So there is a simple way. Once you click on that, again, it will just deploy a function to the cloud. And once it is done, you can push your local code through this button. You see this button? You can see this one. So if you just click on that button, your code goes to the cloud. Okay, so that is a simple way. I've already done it, so I'm just going to click deploy function. Because we changed the code, I'm selecting the same function which I'm using. So I'm selecting that, and it says okay, deploy. Okay, it says basically I'll replace the thing which is there. I'm okay with it, and it is getting deployed. So the new code is going there, and we will see what is this new code will do. And that's exactly, it takes some time. I don't record. So yeah, so let's see from my Twitter. Is there anything coming? So this is the one which I tweeted in the morning. So we will wait for the deployment to complete. So you can see the output here actually, how exactly this is deploying. You can see a couple of things. It is unpacking and unpacking and then deploying the stuff to the cloud. I'll come back to the cloud. So this is the link where it is deployed. So I just need to copy this link and right, and I'm going to show you copying this cloud code, sorry, link, and I'm just saying name is equal to Vivek. So no, just Vivek is also fine. No. Let's see. So you can just see, saying it's just a status. It is telling me Vivek, the API tweet testing completed, right? So it's just telling me some information. But let's see on my Twitter whether it did. Is there no? So this is what it is. So that's what functions does, right? So it's a simple job. It's a simple thing. Every time I run this particular thing, it gets tweet done. I could build very complex things from here, right? All I can do is connect to a database, connect to a Cosmos DB. I could have my proper tweets set, and whenever I'm running this job, it picks up the latest tweet and runs it automatically. Now I could even build it even more complex by telling, why don't you push the same content on LinkedIn, on my different places where my socials are there. I could build an app out of it. Right? So all I have to do is I'm doing is just running a simple function, but it is doing much complex things at the back end just by using APIs and other things from different things, right? So this is what the functions can do, and this was a simple example which I just wanted to show you. And you can run it locally as well. When I say run it locally, that means you can go here, you can see my this is the serverless API, correct? So this is what I have the code, everything set here. I have to do function start. Okay, I'm starting in some port because I don't want to clash with the port which is there. Oh, sorry, not this one. I am sorry. Let me do it from here because I need to install the packages, right? So I'm going to run it from here. It's the debugger which I have chosen, and I can just go here and click on the start debugging, and it will start debugging for me. Okay, so I can do it from here easily because it required some packages to be installed. So I did, and it is on local now. If you see this is on local. Ignore the errors which is it's showing. It's on local. The same thing. I'm going to run. Oops, did I miss something? It should be. Oh no, I think this is also clashing here. Oh yeah, let me close this. Let me see this. This is what happens. Oh, it's not running in local. Hmm? I know, no. Let me rerun it from here. Let's see. Hope it runs. Did it install everything required? It should be fine. Or did I change anything in the code which is not running? I don't know why it is not running in local. So, anyways, so it is running in cloud. I'll have to debug it more, but that's fine. So basically, this is how you can do the test and verify and run it. Uh, Let me go back to, because of the time, let me go back to the next set of things. You can go and take up this challenge, or there is learned reactor we have. That's exactly, we are going to debug these kind of things. We are going to debug hands on. You can also come here and try it out. We have it next week, Friday. You can try the functions on your own. There will be sandboxes available for you, so you can easily try all of these things. So next Friday we are meeting here again, only to do this hands on. So, and obviously it is available online as well, so you can obviously attend online as well if you're willing to try it online. Otherwise you can be here, build it, deploy it, spend 3 hours, 4 hours, 5 hours. The reactor is open on that day. Okay, so a couple of sample examples which I wanted to show you was the web application backend. So the what it does is, basically, if you have an online ordering system, right, uh, and if you see here, it's a simple request which you can make, and there is a http trigger, there's a function, it is just storing data, right, whenever you do an online ordering or anything. So these are the couple of examples, right? Then there is mobile application backend. If you are building an application, mobile application backend, say for example, your friends, you have gone outside, and you want to send notification to all of your friends to pay back these many this this is the cost. And if you want to send notifications, you can still build this through an app, right? So that is how what it is doing. So if you see, there are different set of triggers. Basically, the one is getting triggered from a Cosmos DB trigger, the other is getting triggered from a HTTP trigger. So there are different set of triggers being used in the same application, and it does two different jobs, and it runs two different things, but it is, at the end of the day, if you see, it's sending notification. Similarly, in a manufacturing industry as well, there is anomaly detection happening. So there is a IoT hub, you're sending in data, and there is some condition, at some condition it gets triggered, and the function is getting triggered to send a message to the person who is supposed to fix those problems. So all of these things can be built through functions. You don't really need an infrastructure. You don't need to create a VM or create something else where it is always running for and you're paying for it, and these things never happen, right? So these things never send out, right? You never send out any of these things, right? So similarly, in hospitals as well, right? Sorry, in the vacation planning system, or importantly in healthcare as well, right? So there is bunch of PDFs if you want to work with, and you store it in some blob storage. And this is a blob storage trigger, which is an example of blob storage trigger, where data is there in the blob storage, and basically it is getting pulled, and here is where cognitive services are coming as well. You can run through cognitive services and store it in databases. So yeah, so bunch of things like this, when you're scheduling task or real time streaming process, you're running couple of things to build dashboards, or you're running some SaaS applications, is where you can use. That's something which you can do. And any questions you have, do let me know. So I'll take the online questions first, because there's a bunch of questions would be there, and then I'll come back to you. And after the event also I can be here, so that's the reason. Mm, there's bunch of people. Okay, 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 okay. Okay, there's bunch of questions there which I will answer through chat itself. So it will take a lot of time to answer those things. Uh,
Like, can we build a API from Notion to LinkedIn if I want to schedule my post from Notion to LinkedIn? Is it possible to do like that?
Yes. So the question here is, can I build a app where I can schedule and create a scheduler to uh, post something onto my social handles? Yes, you can do it. You can use bunch of triggers as well, like the timer trigger as well if you want to schedule it, or you can use the normal trigger which I have used, and also run it whenever on requirement basis. That is also been, you can do it.
Yeah, currently Notion doesn't have few connections between apps like Notion and Google can create this API. Can you build an API where they're not having connection between apps?
When you say, what do you mean by connection between apps?
Let's say if I want to take data from one of the app to the other app, and there is no API currently for them.
Huh.
Can we use Azure and
Yes, definitely it is being used. One of the use cases you saw, right? You can push all the data to the blob storage, and from blob storage you can trigger it to Azure uh, through the functions, and you can basically structure it and store it in Cosmos DB or any other places.
Like, can we use API is there? Can we replace API
Huh.
with this? Can we try to build our own API kind of?
You can definitely. Zapier is just an integration tool,
That's why
and you can definitely build it through functions using logic apps as well. But again, these are all set of things you can use in different use cases. There are bunch of use cases, so you have to go through these use cases which is there, and there are best practices, because you can do it in different ways. You can obviously go back and pay for Zapier and use it as well. So otherwise you can use it through building your own functions, or you can use probably logic apps as well, build it with different integrations with logic apps, based on your integrations your requirement is. Yeah.
So considering it's a stateless, so connecting with the Azure function is going to be difficult in this scenario because you said Azure function is stateless, right? So how is it going to maintain the connectivity between different, like you have multiple chunks of Azure function and then the interaction has to happen?
There is something called as durable functions, where you can have the states maintained between different functions, and then update it as well. So there is a way to do it. I haven't shown that here because of the complexity it will bring in for the first timers, right? If you're not familiar with functions as a platform, it will add complexity. So that is the reason why we didn't discuss it. Probably we can discuss that when we do the learn it reactor next week. We can definitely do that. Any other question?
Is it free or how much does it cost to pay using any for our personal use, like if we're trying to use it?
It's basically different consumption plans are available. So you can take a look at that. Some of these you can run it as an app service plan where there is a free trial as well. Otherwise, yeah. Yeah. So while we are discussing, I will let the other speaker come here and he set up his setup, because I'm going to go offline from this now. The speaker will come here. So while you can still ask questions here, I can. Share your screen. Just play this. You need to add his screen.
Yeah, everyone. Good evening for everyone. Yeah. Yeah. Before going into the topic, I want to introduce myself. Actually, I am Tarunan Ganesan. I am having around 8.5 years of experience in industrial Internet of Things, and then actually I have been currently working in L&T Infotech as the specialist in industrial Internet of Things, and been handling around 3 to 4 teams of developers. And then also actually, if you think I have been predominantly working on Microsoft based on IoT services like Azure IoT Hub, and then Azure Event Hub, storage accounts, and then Azure Digital Twins, ADX clusters, Databricks, etc. And then actually, if you see now today, actually, what topic we are going to see is currently it's about the Azure Digital Twins. Actually, why I chosen this topic is actually since Microsoft has been predominantly giving updates about this digital twins in the past is 5 to 6 months actually. So I thought actually it's a right time for to tell the people or tech technologies actually going around and predominantly using these Microsoft services for the IoT based projects. And moreover, what is the importance of using this Azure digital twins in your project is actually you can visualize your 3D model of your asset, and we can also it's been used to see the real-time data, the telemetry data which is coming into your which is coming from an asset actually will be viewed in a 3D model. And moreover, actually since actually it is invented actually so that it's not necessary for a workman to go to the many type of fields, and they need to monitor the things on the manual part actually. So this is what actually we are going to see in this next 45 minutes, and it also includes some demo as well. So in this demo actually, if you see, I will be talking about how to create Azure digital twin instance, and I also will tell you about what is a Azure digital twin explorer, and how the DTDL models has been created actually, and which format you need to create this DTDL models, and what are the components which needs to be there in the DTDL model, which is necessary for creating the 2D graphs for this digital twin data explorer. And then actually at last actually we have been going to see about the 3D Scene Viewer actually. The 3D Scene Viewer is nothing but is a kind of a studio which is introduced by Microsoft to see the 3D based model of your assets which you are going to monitor, or you are going to do some configurations and all actually. So let's move on to the topic.
Check now. Okay, check now.
Audio, it was selected in the, not the mic, it was selected in audio.
No, no, it's good. It's good. It's good.
Okay, actually, if you see the 3D model might be any type of assets like your building or factories or farms or energy models, etc. And also, if you see, it is used to this Azure digital twin will be used to expand your IoT cloud architecture actually in a wider space by implementing these 3D models in your applications or solution. And then actually, if you see. Most of them actually will be get confused regarding this device twin and a digital twin actually. The IoT device twin is nothing but the device twin which has the properties of your device which is getting created in your IoT app. But if you see the digital twin is a completely different from the device twin, that it it will only actually gives a 3D model representation along with the telemetry data coming into your cold part and hot part of your architecture actually. So this is a difference of this the difference between this IoT twin and the digital twin actually. Okay, if I include digital twin in my architecture, actually, what are the benefits the client can be able to achieve? Is the question will come across in every projects actually, like yeah, because actually, yeah, we are investing this much money in this particular service, but what is the outcome I can get it for, as in return of my investment, like that. These kind of questions will come. So yeah, for it, if you see, it will bring the any environment to the live, and it also will make the things in a the scalable and a secure manner actually. And it also has um, it will help us to connect the existing assets which are available in your in existing environments actually. Then it also used to build any system in a robustable manner actually. And then if you see, in actually this Azure Digital Twin Data Explorer, if you see, we can be able to query the each and every telemetry data which is coming into a particular asset actually. So these are actually it's an important one actually, where a particular developer can be able to check and see actually if the data flow is continuous or not in their assets. If in case actually this data flow is not continuous, means actually, yeah, they can set up an alert, and they can bring it can be alerted to the respective teams for making the things in a good way actually. And then after, if you see, it can also be integrated with AI services, ML services, and then actually analytics services and data services of Azure as well actually. So these are some of the advantages of the digital twin. And then if you see, this digital twin, they'll be working on some models actually. Okay, in these models actually, you need to follow a particular thing called actually DTTL. DTTL is nothing but is it's a digital twin definition language actually, where the data should be given in the form of a JSON, with which some components has to be followed actually. So in the upcoming slides actually, we are going to see that only. Before and all, if you see, before in the introduction of this 3D Scene Studio of Azure Digital Twin actually, we need to write this model manually, and we need to upload it into the data explorer actually. But if you see now actually, since the 3D Scene has some features to upload the data directly to that configuration page, and then it will be directly generating this model file actually, and in terms of sparing out time by writing it in a manual one actually. And if you see, what are the formats will be accepted in this digital twin explorer. Yeah, what types of style formats I can be able to upload, means actually, if you see, you can upload the JSON style format and in Excel formats for in your digital twin explorer to get the models to be uploaded to make a graph actually. Okay, and then if you see, there are some elements of DTDL which has to be mandatorily followed by creating your DTDL based model structure. Some of them are actually these some of the main one actually. It has so many things actually, but these are the most followed components of the DTDL language, like interface, telemetry, relationship, property, command, and its component actually. So if you see, if you are going to write a particular DTDL based the JSON format, means actually these type of components are mandatorily has to be there. So it will be easy for your models to be mapped with their respective twins when you're creating a graph actually. So yeah, we will see one by one. If you see, we can speak about in interface actually. First, the interface is nothing but actually it's a kind of representation of a particular contents of the digital twin, like its properties or inheritance, etc. And then actually this interface can be used for this schema for components in another interface also actually. Yeah, for example, if I have an interface called thermostat. This thermostat interface can be used in another interface or another DDL file as well actually. So this is about this interface. And then actually if you see telemetry is another component. For example, if you see my type can be a telemetry or property actually. Telemetry means actually it will not for example, if my data is coming from an IoT hub actually, so it has to be ingested to a digital twin actually. In that case actually the digital twin won't store the data. Instead actually it will keep on utilizing the data's values only actually instead of avoiding the storage part actually. So in this case telemetry will be a very useful one if you have millions of devices connected and it's sending the data to these digital twins actually. Command, if you see it's a type of function or type actually which needs to be performed in your DTDL nodal file actually. For example, if you see I have a command called deboot actually. Okay, in that action I have been need to give a description called requested time to deboot the device, and how the schema has to be. It should be a date time actually. At what date and time actually it has to be rebooted. So this is the format of the command which we are giving it to the DDL model actually. And then if you see property, any property of your the visual twin has the read rate of operations actually. For example, I have a property called temperature which can be only a read only, or I have a property called device ID which can be a read only actually. But if I have property called on or off actually, it can be a writable actually. I can be able to write that property as a on or off actually based upon my machine status or the status of my the missionaries has to be utilized in the future actually. So these are the things if you see will be play a major role while creating this DDDL model. And next one, if you are going to see is in relationship. Yeah, for example, relationship is nothing but kind of an inheritance kind of one actually. If you see, for example, I have one house in a second floor actually. Okay, in that house I have n number of rooms like kitchen, bedroom and bedroom to etc. Okay, but the main pin in that particular model will be my house number 2 actually. So that this room number 1, room number 2, kitchen and hall and all will combine as a relationship to this house number 2 actually, which is at this second floor. So in that case you can map n number of relations between n number of digital twins based upon their actually their commands or any type of the business use cases actually. Okay, so and then if you see we are going to see about component is nothing but actually it will describes us clearly the connectivity between the two interfaces actually. Okay, so this component will play a major role. For example, the component 1 actually interfaces with the component 2 means actually the component 2 has the properties of the component 1 as well actually. So this is the purpose of this component tag in this DDDL model. Okay, next we'll be seeing a small demo actually in which I will be showing how to create this digital twin explorer, digital twin instance, and this PD scene by using some small IoT based use case actually. Okay, like this only actually this digital twin explorer will be there, and like this only actually your 3D scenes the build view will be there actually. So these things we'll be seeing it now in this demo actually. Okay, portal, it's on portal. No, it's on portal actually. Before going to this actually creation of this Azure Digital Twin. Yeah. Yes. Okay.
Are we trying to put the coordinates with the respective Excel and then trying to form the model? Or is it can also we use cameras of real time maybe to like
Yeah, you can create a TD based model actually.
Can you repeat the question to the online audience as well?
Yeah, actually, what is the question you asked actually? Can you please tell me?
like are we using coordinates to take it, push that into Excel and form a virtual kind of a model, or can we also use 3D and kind of cameras also real time kind of a model we can also use there?
Okay, actually, this is a question raised by Mr.
Right.
Mr. Roy, that actually that yeah, there we need to use only the coordinates based in Excel data only to create these models, or actually we can use a real-time 3D captured data also for these models actually. Yeah, we can use the both the things actually. Okay, before actually, if you see, only a 2D based model was available. In that case, actually, only the Excel or this DDL based on formats are used. But now, if you see, after this introduction of this 3D scene, you can create a 3D model of your asset actually, which should be in the format of .glb actually, which is a 3D printing. Extension format actually. I hope so. Why it is used means actually this extension will be very much clear, and it's very small in size as well actually. So only this .glb based 3D models are used actually. Okay, and it can be created using your the 3D paint itself actually, which is available from your the Windows 11. Okay, so both the things are possible actually.
Also like oculars.
Yeah. Actually, yeah, Oculus also the file which you are getting generated in Oculus or any AR/VR device should be in the format of the GLB actually. So if you get those files means actually of a particular real model means actually it is better actually you can upload that same thing to your this PDC, and you can map the elements and all actually. So that's what we are now going to see actually, how it will be done like that actually. Okay. Before going into it actually, whenever you are actually going to create any new services in your Azure portal, or you are going to create any services for your project, or you need to create a new resource group actually. Okay, yes, already it will be easy for you to give access for your particular team members or anyone kind of, or for the costing purpose also it can be utilized. So in that case actually I created a resource group called ADT Reactor. Okay, in the under this ADT Reactor action, I have been created a digital twin called ADT Reactor Bangalore Twin actually. Okay, so how I created this one means actually you have since an ADT is a Azure Digital Twin is a PaaS service. If you go here and you can choose the digital twin and create, you need to give your subscription and your which resource, under which resource group you need to create the twin, and then actually what is the name of your ADT instance, and then your region, under which region and please without any forget, please tick mark this, because once you give the owner role to your Azure Digital Twin only, actually it can be able to get the data without any seamless from your Azure IoT Hub or given top like that actually. Okay, so this is how I created the Azure Digital Twin. So if you see, after you giving this give you press create actually, that digital twin will be created. Once the deployment is completed, if you see, it will look like this. Okay, like it will look like this with this host name. Is a host name will be, it's very much important actually. It will be used in various places of creating these twin models and all. So please make a note of this host name. And also actually, if you see here actually in you will be having a open Azure Digital Twin Explorer actually. So if I click this actually, it will open this Explorer for me. Okay, this Explorer actually gives you the entire view how the 2D models are created. So before going into this, actually, I will tell you how I generated this telemetry data by means of some simulator actually. Okay, so if you see, this is a data pusher simulator, which is uh, which is used by Microsoft to create a quick simulator actually for some TOCs and all. Okay, so if you see here, uh, once this stage gets loaded, actually, you can see it will ask for your digital twins instance URL actually, and it also asks what kind of simulation type you want. You want robotomes or dairy facility. I'm actually currently going with the robotic arms actually, and then this instance URL has to be taken from here actually. The host name only is an instance URL of your the Azure digital twin. Okay, once if I give this actually and generate an environment, means actually it will create an environment of packaging uh, physical actually, and with robotic norms of 5 to 6 machines will be created actually by sending some random telemetry data to my digital twins actually. So if you see, once if I create a generate an environment and start simulation, so the data here actually, if you see here, like this actually the model will be created in my PPT. If you see, I might have actually speaking about these models and all. The new model, if I see by creating this new model, the components, the interface, the relationship, which and all I have been told here has been created. But earlier, if you see, actually, this file has to be manually created by the developer, and it needs to be uploaded and mapped to your digital twin explorer. So since this data simulator has been introduced by Microsoft, now my job is getting completed easily actually by giving the what kind of simulation type I want actually in which environment. Okay, and then if you see, if you click each and every this is a distribution center which has actually 6 robotic arms. Okay, inside this the DT ID means actually the digital twin ID of this this model is actually DISTCTR actually. Okay, this distribution center has been connected to 6 robotic arms actually, which generates a data of uh, how many pickups has been failed in the last hour, and what is the hydraulic pressure, and how much alerts has been sent actually while the failure has been happened. And then actually if you see actually which box ID has been failed to pick up, like that, and all the data will be generating here from the simulator actually. Okay, so this is the 2D model representation of your Azure digital twin model, which is associated to this distribution center robotic norm simulation type actually. Okay, so if you want to see the 3D model of this, means actually you need to get the 3D model of this particular robotic model distribution center area, which contains 6 robotic norms actually. Okay, and then actually that has to be fit into your 3D scenes actually. So next we are going to see that one. Yeah, before going into that actually, we need to create a storage account container, so which gets the tiles of the this 3D scenes uh, tool actually. Okay, so actually, I have been set my subscription ID as this actually, and then actually I want to now create a storage account for this particular resource group and its subscription. So if you see here, it can be created like using your Azure CLI as well, and it can be created using the Azure portal as well actually. Okay, so if you see here, I am creating it here using the CLI, so it will be easy for us to assign the ownerships and all actually, and the access related policies as well actually. Be creating as East US, and then actually if you see, so it will create my Azure Digital Twin storage account actually in my resource group, ADT reactor. So take some time. Once this has been completed, actually, it will be giving the idea of your storage container. So that has to be noted down actually. Yeah, yes.
Can it be used to like simulate like doctor doing operation here and a digital robotic arms doing operation in a healthcare place? Can this be replicated?
Yeah, anything which is based on your use case, actually, you can create it actually. Okay, yeah, yeah. Actually, yeah. As of now, Microsoft released two stimulator types only, like robotic arm, which is ticking the box actually, and it's also yeah, dairy farm based. Yeah, dairy farm based actually, one stimulator type actually. So in future we are expecting a lot of stimulators like this. It's like you've been if you're working in this IoT accelerators actually. So if you see, we have a number of stimulators has been designed by Microsoft actually, which is closely associated and sending the data in IoT central service actually in Azure. So like that, they are actually trying to build it. Once it's completed, actually, we can get a number of simulators. In case if you yeah, there is no any particular stimulator which suits your use case, means actually you can create your own DTTL model in your using a JSON or the dynamic mapping of an Excels and all. And you can still upload that into your Digital Twin Explorer actually. So both the ways it's been working out actually. So if you want to customize your use case, and then you need to do it as well actually.
The internet 5G would be the essential for the internet of
Which one?
5G speed of internet. 5G would be the speed of latency because
Yeah, actually, 5G would be a good option. Once of the evolution of the 5G was more actually. In that case, if you see, this digital twin, this 3D viewers and all, actually, we using the AR VR devices also will be a boom actually in the world. Okay, so it's taking some time to create the storage account. Okay, let it be. I will also you will actually yeah, show you the 3D scenes in the environment actually, where the 3D scenes will be created actually. If you see, I already have a storage container in my account, so I am making utilize of it instead of waiting for it. So if you see, container has been created, and then actually if you see, there's a HTTPS, and then is an address of the container will be mapped here actually. So I can keep my container name as to add this container to my actually the visual twin. The course has been enabled first actually, and then only actually if you see this uh, there will be there won't be any flawless activities will get happen. You see, if a course is not handled here actually, the data will not be blended with our 3D scenes actually. Sorry, my session got expired actually in here, so I will be re-logging in. Okay. Okay, once I give
And was it in private or public?
it's actually in public actually. I need to change this into private one actually. Okay, don't know what's the is might be my access issue. I hope so actually. So if you see actually once we give this URLs here actually, it will ask for your .glb file to get uploaded actually. So once your .glb file got uploaded actually, this as I mentioned in this KPT actually, you will be able to see this entire the 3D models, and then if you click on each and this robotic DOM actually, yeah, you can view what kind of events has been triggered, which any alert has been triggered or not has can also be viewed on this plot actually. So this is what actually the 3D screen the tool of the Azure has been performing now actually. So this is about the digital twins of Azure. So yeah, is there any questions?
So like IoT central auto connections, right? IoT central connections.
Yeah,
It starts breaking.
starts. Yeah, actually, IoT Central actually, if you see, can be connected to this digital twins. Actually, you can send data from your IoT Central also to this digital twin, and from IoT Hub also you can send directly, or by means of Event Hub and Azure functions also. You can send the data directly from here. Actually, you can able to egress the data to your Azure Data Explorer, Azure Synapse, and all actually for some analytics and AI based services.
So is it like the model should have the like or the infrastructure should have attached with the IoT devices only? It is limited to that, or can we take the 3D printing from different angles and just import the data to that?
No, actually, it's actually completely based on real-time data which is coming from your asset actually or from your simulator. So it's actually completely associated in IoT-based ecosystem only.
And it is different from time series insights.
Yeah, time series insights actually it's completely it's a kind of in visualization tool like our Power BI where we can do some analytics based upon your requirements actually. But this is actually completely it's a kind of PD visualization of your asset which is in front of you. So which tells about the various big data which is coming from your telemetry to your model presentation actually. So both are different actually. Yeah, yeah. Thank you, everyone. Actually, it's been great in presenting this topic of yeah, digital twins. Thank you for this opportunity for the Microsoft Reactor. Actually, thank you so much, team. Yeah, bye. Take care.